An explosion is a rapid increase in volume and release of energy in an extreme manner, usually with a generation of high temperatures and the release of gases. Supersonic explosions created by high explosives are known as detonations and travel via supersonic shock waves. Subsonic explosions are created by low explosives through a slower burning process known as deflagration. When caused by a man-made device such as an exploding rocket or firework, the audible component of an explosion is referred to as its report. Causes Natural explosions can occur in nature. Most natural explosions arise from volcanic processes of various sorts. Explosive volcanic eruptions occur when magma rising from below has much dissolved gas in it. The reduction of pressure as the magma rises causes the gas to bubble out of solution, resulting in a rapid increase in volume. Explosions also occur as a result of impact events and in phenomena such as hydrothermal explosions. Explosions can also occur outside of Earth in the universe in events such as supernova. Explosions frequently occurred during bushfires in eucalyptus forests where the volatile oils in the treetops suddenly combust. Animal bodies can also be explosive, as some animals hold a large amount of flammable material such as animal fat. This, in rare cases, results in naturally exploding animals. Astronomical. Among the largest known explosions in the universe are supernovae, which result when a star explodes from the sudden starting or stopping of nuclear fusion, and gamma-ray bursts, whose nature is still in some dispute. Solar flares are an example of explosion common on the Sun, and presumably on most other stars as well. The energy source for solar flare activity comes from the tangling of magnetic field lines resulting from the rotation of the Sun's conductive plasma. Another type of large astronomical explosion occurs when a very large meteoroid or an asteroid impacts the surface of another object, such as a planet. Chemical. The most common artificial explosives are chemical explosives, usually involving a rapid and violent oxidation reaction that produces large amounts of hot gas. Gunpowder was the first explosive to be discovered and put to use. Other notable early developments in chemical explosive technology were Frederick Augustus Abel's development of nitrocellulose in 1865 and Alfred Nobel's invention of dynamite in 1866. Chemical explosions are often initiated by an electric spark or flame. Accidental explosions may occur in fuel tanks, rocket engines, etc. Electrical and magnetic. A high-current electrical fault can create an electrical explosion by forming a high-energy electrical arc which rapidly vaporizes metal and insulation material. This arc flash hazard is a danger to persons working on energized switchgear. Also, excessive magnetic pressure within an ultra-strong electromagnet can cause a magnetic explosion. Mechanical and vapor. Strictly a physical process, as opposed to chemical or nuclear. For example, the bursting of a sealed or partially sealed container under internal pressure is often referred to as a mechanical explosion. Examples include an overheated boiler or a simple tin can of beans tossed into a fire. Boiling liquid expanding vapor explosions are one type of mechanical explosion that can occur when a vessel containing a pressurized liquid is ruptured, causing a rapid increase in volume as the liquid evaporates. Note that the contents of the container may cause a subsequent chemical explosion, the effects of which can be dramatically more serious, such as a propane tank in the midst of a fire. In such a case, to the effects of the mechanical explosion when the tank fails are added the effects from the explosion resulting from the released propane in the presence of an ignition source. For this reason, emergency workers often differentiate between the two events. Nuclear. In addition to stellar nuclear explosions, a man-made nuclear weapon is a type of explosive weapon that derives its destructive force from nuclear fission or from a combination of fission and fusion. As a result, even a nuclear weapon with a small yield is significantly more powerful than the largest conventional explosives available, with a single weapon capable of completely destroying an entire city. Properties of explosions. Force. Explosive force is released in a direction perpendicular to the surface of the explosive. If a grenade is in midair during the explosion, the direction of the blast will be 360 degrees. If the surface is cut or shaped, the explosive forces can be focused to produce a greater local effect. This is known as a shape charge. Velocity equals, the speed of the reaction is what distinguishes an explosive reaction from an ordinary combustion reaction. Unless the reaction occurs very rapidly, the thermally expanding gases will be moderately dissipated in the medium, with no large differential in pressure, and there will be no explosion. Consider a wood fire. As the fire burns, there certainly is the evolution of heat and the formation of gases, but neither is liberated rapidly enough to build up a sudden substantial pressure differential and then cause an explosion. This can be likened to the difference between the energy discharge of a battery, which is slow, and that of a flash capacitor like that in a camera flash, which releases its energy all at once. Evolution of heat equals, the generation of heat in large quantities accompanies most explosive chemical reactions. The exceptions are called entropic explosives and include organic peroxides such as acetone peroxide. It is the rapid liberation of heat that causes the gaseous products of most explosive reactions to expand and generate high pressures. This rapid generation of high pressures of the released gas constitutes the explosion. The liberation of heat with insufficient rapidity will not cause an explosion. For example, although a unit mass of coal yields 5 times as much heat as a unit mass of nitroglycerin, the coal cannot be used as an explosive because the rate at which it yields this heat is quite slow. In fact, a substance which burns less rapidly may actually evolve more total heat than an explosive which detonates rapidly. In the former, slow combustion converts more of the internal energy of the burning substance into heat released to the surroundings, while in the latter, fast combustion instead converts more internal energy into work on the surroundings. Compare heat and work are equivalent forms of energy. See heat of combustion for a more thorough treatment of this topic. When a chemical compound is formed from its constituents, heat may either be absorbed or released. The quantity of heat absorbed or given off during transformation is called the heat of formation. Heats of formations for solids and gases found in explosive reactions have been determined for a temperature of 25 degrees Celsius and atmospheric pressure, and are normally given in units of kilojoules per gram molecule. A negative value indicates that heat is absorbed during the formation of the compound from its elements. Such a reaction is called an endothermic reaction. In explosive technology, only materials that are exothermic that have a net liberation of heat are of interest. Reaction heat is measured under conditions either of constant pressure or constant volume. It is this heat of reaction that may be properly expressed as the heat of explosion. Initiation of reaction equals, a chemical explosive is a compound or mixture which, upon the application of heat or shock, decomposes or rearranges with extreme rapidity, yielding much gas and heat. Many substances not ordinarily classed as explosives may do one, or even two, of these things. A reaction must be capable of being initiated by the application of shock, heat, or a catalyst to a small portion of the mass of the explosive material. A material in which the first 3 factors exist cannot be accepted as an explosive unless the reaction can be made to occur when needed. Fragmentation equals, fragmentation is the accumulation and projection of particles as the result of a high explosive's detonation. Fragments could be part of a structure such as a magazine. High-velocity, low-angle fragments can travel hundreds or thousands of feet with enough energy to initiate other surrounding high-explosive items, injure or kill personnel and damage vehicles or structures. Notable explosions. Chemical explosions nuclear testing Trinity test, Castle Bravo, Tsar Bomba, atomic bombings of Hiroshima and Nagasaki. Use in war artillery, mortars, and cannons, gunpowder and smokeless powder as a propellant in firearms and artillery, bombs, missiles, rockets, and torpedoes, atomic bombings of Hiroshima and Nagasaki, land mines, naval mines, and IEDs, satchel charges and sapping, hand grenades. Volcanic eruptions Santorini, Krakatoa, Mount St. Helens, Mount Tambora, Mount Pinatubo, Toba catastrophe theory, Yellowstone caldera. Etymology, Classical Latin explodere means to hiss a bad actor off the stage. The modern meaning developed later. See also. References